All right, so people, good evening and welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly, my dear students, let me know in the chats with some fire emojis, yeah? With some fire emojis. With some fire emojis. If all of you can hear me, if I'm perfectly audible and visible to every one of you. Yeah? Quickly, let me know in the chats. Quickly, let me know in the chats. Quickly, let me know in the chats. I would want the chats to be rolling continuously in the today's session. Well, this is our first session of the Phoenix 2.0 NEET English batch, which we have kept on YouTube so that everyone can watch this particular session out. Yeah? Right? Right, people? So quickly, let me know in the chats. I believe all of you can perfectly hear me. I believe all of you can perfectly hear me and see me. That's amazing. That's amazing. So one common question which I would want to ask you, right? Can you let me know in the chats where are you guys exactly from? Write down your states. I just want to know. I just want to know. Where are you guys exactly from? Write down your states in the chats. All right. I can see majority of the students are from South. Tamil Nadu, Karnataka, AP, Andhra. All right. All right. Perfect. 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 As I told you already, this is our first session, which is going to happen on YouTube, and all the other sessions from now onwards, apart from this session, they are going to happen on the Unacademy platform, Unacademy app, right? So first session, we have kept it free for everyone so that everyone knows how exactly we are going to start the batch. Yeah? Perfect. So people, are you all ready? Are you all ready? Well, the ones who do not know me, my name is Wassim Bhat, and I will be taking care of your chemistry in this particular Phoenix 2.0 NEET English batch, right? And as I kept on telling you all the time, whatever chapter we shall be starting, every chapter we shall be starting from the basics, from the scratch. Whether you have studied the chapter before or not, it does not matter. It does not matter. I will be starting as if you have never started, as if you have never studied the chapter before. Right? Right, people? I know you guys already had Yavar sir's session today and he was amazing. I heard that. Yeah, he was amazing. You loved that particular session. That's wonderful. You are going to love all the educators, be it Ambika ma'am, be it Pankhudi ma'am, be it HSP sir, right? All the educators from your Unacademy NEET English team, you are absolutely going to fall in love with everyone's teaching, guys. That is my promise. That is my promise. Yeah, that is my promise. You need not to worry. Since I personally have taken the responsibility of this particular batch, so you will be, throughout this particular year, you'll be under our guidance, our under mentorship. We'll keep on letting you know all the time, right? What to do, what not to do. Everything, one-on-one interactive sessions will be kept with all of you after you write the weekly tests which we have scheduled in this particular batch. Yeah? Perfect? Perfect, people? So are you all ready? Are you all ready? Are you all ready? Quickly in the chats. Are you all ready? Let me know in the chats. Let me know in the chats quickly. Are you all ready? Yes? Perfect, perfect, perfect. Wonderful. And the ones who have not joined into the batch yet, right? You can still join in. The link is there in the description box of the video and be the part of Phoenix 2.0 NEET English batch, right? Today we are starting its classes. The first session is this one, which is happening on YouTube. From tomorrow, all the sessions will happen on Unacademy platform. So the ones who have not joined in yet, you have still got some time to join into the batch as soon as possible. So let's get going then. Let's get started with the first chapter of our class 11th chemistry. With the first chapter of our class 11th chemistry. And my dear students, you all must be knowing about the name of the chapter. That is some basic concepts of chemistry. This is our first chapter, my dear students, which is going to form the basis of your complete chemistry. This particular chapter is going to form the basis of your complete chemistry. Let me tell you, if this chapter gets strong, then your entire physical chemistry is going to get strong. If there will be some issues in this chapter, any sort of issues in this chapter, that means there will be issues throughout your physical chemistry, right? So make sure you make this particular chapter strong, which we are going to help you out in, right? We just want you to follow all the sessions, right? And once we complete the chapter, the DPP and the study material, which we are going to provide you, please and please solve that DPP, solve that study material, right? And once we complete the chapter, I'll have the PYQ session of this particular chapter as well, in which I shall be discussing 5 to 10 year PYQs of this chapter, right? I'll be taking one more session of this particular chapter wherein I shall be solving the NCERT in-text as well as the exercise questions. So just follow the things sincerely with proper sequence. Just follow what we tell you to follow. My dear students, it's going to be a piece of cake for all of you. So let me know in the chats now if all of you are ready for the session. Quickly, people, quickly. Session PDF, I'll share you in the Telegram group. I'll share with you in the Telegram group after the end of the session, right? After the end of the session, I shall be sharing the session PDF in the Telegram group. Perfect. Exactly. I shall be starting the chapter from the scratch. Whatever things I'll be noting down on the screen, I would want every one of you to take a note of every single thing. Every single thing. My dear students, you will have to make the running notes. So with me, you will keep on writing the things, right? Not just only in my session, in Yavar sir's session also, in Ambika ma'am's session also, in HSP sir's session also. In all the sessions, you will have to take the handwritten notes. You will make the notes on your own. Okay? Perfect. Chalo. Let's get going then. Let's get started. I have kept everything handwritten today. I'm not going to use any sort of slides over here. Everything, whatever I'll be teaching you, it's going to be completely handwritten. Okay, so that you also get time to take down things with me. Okay? Perfect. All right, people. So let's get going. Let's get started with the first topic of the first chapter, and you already are familiar with this topic. What is it? What is it? The term is atomic mass. This is the first and the basic topic which we are going to start with in this particular chapter. Atomic mass. My dear students, there are many definitions when you talk about the term atomic mass. The first and the simplest definition of the term atomic mass, I'm going to note down on the screen first. Then I'll make you understand what is the meaning of that definition. Okay? Have a look, people. Atomic mass, its simplest definition. It is defined as the mass of one atom of an element. It is defined as the mass of one atom of an element. My dear students, all of you must be knowing, in your periodic table, how many elements do we have? In our periodic table, we have got in total 118 elements. In our periodic table, we have got in total 118 elements. The term atomic mass is basically defined for what? The term atomic mass is basically defined for elements. The term atomic mass, it is basically defined for elements. Every element in the periodic table, it has got some atomic mass. Now, what is the meaning of the term atomic mass? My dear students, atomic mass is nothing. It is just the mass of one atom of an element. It is just the mass of one atom of an element. For example, if I ask you, what is the atomic mass of oxygen? What does that mean? That means I'm asking you, what is the mass of one atom of oxygen? What is the mass of one atom of oxygen? If I ask you, what is the atomic mass of sodium? What does that mean? That means I'm asking you, what is the mass of one atom of sodium? If I ask you, what is the atomic mass of fluorine? What does that mean? That means I'm asking you, what is the mass of one atom of fluorine? So in short, my dear students, whenever from now onwards, I ask you about the atomic mass of some element, that means I'm asking you about the mass of one atom of that element. I believe I'm clear to everyone. I believe I'm clear to everyone. So how do we define the term atomic mass? Atomic mass is defined as the mass of one atom of an element. Mass of one atom of an element is something which we call as atomic mass. Now, my dear students, let's try to understand this atomic mass a bit more in detail. Try to understand what exactly I'm going to say. Complete basics I'm going to start with. See guys, for example, let's say I have taken three objects over here. Imagine these are the three objects which I have taken over here. Object 1, object 2, object 3. Three objects I've taken. I'm assuming that the weight of first object is 2 kilograms. I'm assuming weight of the second object is 3 kilograms. I'm assuming weight of the third object is 5 kilograms. I've taken how many objects here? I have taken three objects. The weight of first object is 2 kilograms. The weight of second object is 3 kilograms. The weight of third object, that is 5 kilograms. Now, my dear students, try to understand. This 2 kg over here, I can break it as 2 multiplied by 1 kg. 2 multiplied by 1 kg comes out to be equal to 2 kg. Similarly, this 3 kg I can break as 3 multiplied by 1 kg. 3 multiplied by 1 kg comes out to be 3 kg. Similarly, 5 multiplied by 1 kg comes out to be 5 kg. So how many objects I've taken? I've taken three objects. I have taken three objects. The weight of the first object is 2 kilogram. The weight of the second object is 3 kilogram. The weight of the third object, that is 5 kilogram. Now, my dear students, why did I break this 2 kg as 2 multiplied by 1 kg? Why did I break this 3 kg as 3 multiplied by 1 kg? Why did I break this 5 kg as 5 multiplied by 1 kg? Why did I do that? There is a reason. There is a reason. My dear students, can I say this particular object which I have taken over here, can I say this object, it is 2 times heavier than 1 kilogram? I can say that. Can I say this particular object, it is 3 times heavier than 1 kilogram? Absolutely, I can say that. Can I say this particular object, it is 5 times heavier than 1 kilogram? For example, my weight is 75 kilograms. For example, my weight is 75 kilograms. What does that mean? That means I am 75 times heavier than what? I am 75 times heavier than 1 kilogram. Right? So, my dear students, can I say I am comparing the weights of different objects? I am comparing the weights of different objects with this 1 kilogram over here. I am comparing the weights of different objects with this 1 kilogram. I told you that this object is 2 times heavier than 1 kilogram. This object is 3 times heavier than 1 kilogram. This object is 5 times heavier than 1 kilogram. I am 75 times heavier than 1 kilogram. So basically, I am comparing the weights of different objects with what? With 1 kilogram. Okay. So this 1 kilogram over here, with which I am comparing the weights of different objects, I'll be calling this 1 kilogram over here as the standard. I'll be calling it as the standard, or I shall be calling it as the reference. This 1 kilogram with which I'm comparing the mass of different objects. This 1 kilogram with which I'm comparing the weights of different objects. This 1 kg is my standard with which I'm comparing the weights of different objects. Yeah? Now, my dear students, let me tell you, this 1 kg is our reference. It is our standard in physics with which we compare the weights of different objects. Correct? This is our 1 kg in physics with which we compare the weights of different objects. Now, in chemistry, do we deal with objects? No. We deal with atoms, molecules. In chemistry, we deal with atoms, molecules. My dear students, don't you think in chemistry, we should have similar standard? We should have similar reference like this 1 kg so that we can compare the weights of different atoms or molecules? Don't you think in chemistry, we should have a standard like this 1 kg so that we can compare the weights of different atoms or molecules with that standard? Yes? So basically, how many objects I took over here? I took 3 objects. Weight of first object, 2 kilogram. Second object, 3 kilogram. Third object, 5 kilogram. First object is 2 times heavier than 1 kilogram. Second object is 3 times heavier than 1 kilogram. This object is 5 times heavier than 1 kilogram. I am 75 times heavier than 1 kilogram. So basically, I am comparing the weights of different objects with 1 kilogram. So that 1 kilogram, I am calling as the standard. I am calling as the reference with which I am comparing the weights of different objects. Right? But that 1 kilogram is the standard in physics. So in chemistry, we definitely need a standard like this 1 kilogram. In chemistry, we need a reference like this 1 kilogram with which we shall be comparing the weights of different atoms or molecules. Now the point is, what is that standard in chemistry? Let's try to make that standard in chemistry, people. Let's try to make that standard in chemistry. Okay? Let's try to make that standard in chemistry. Well, my dear students, in order to make that standard in chemistry, what I'll be doing, I will be taking a carbon-12 atom. Let's assume this is the carbon-12 atom which I have taken over here. I have taken a carbon-12 atom, right? I have taken a carbon-12 atom. I'm assuming this is my carbon-12 atom. Now, my dear students, what exactly I'm going to do, I am going to divide this carbon-12 atom into 12 equal parts. I divided this carbon-12 atom into 12 equal parts. After dividing this carbon-12 atom into 12 equal parts, if I take one smaller part over here, one smaller part like this over here, can I say this particular smaller part, can I say its mass is going to be 1/12 of, its mass is going to be 1/12 of the mass of carbon-12 atom? Absolutely. Absolutely. First of all, you should know exactly what we are trying to do. My dear students, we have to make a standard in chemistry with which we shall be comparing the masses of different atoms or molecules. In order to make that standard, which atom did I take? I took the carbon-12 atom. I divided the carbon-12 atom into 12 equal parts. After dividing the carbon-12 atom into 12 equal parts, I just took a small part over here. And I'm telling you, the mass of this small part, it is 1/12 of the mass of carbon-12 atom. Let me tell you, 1/12 of the mass of carbon-12 atom, from now onwards, you are going to call it as either 1 AMU, or you can call it as 1 U, or you can call it as 1 D. You can call it as 1 D. Let me tell you, people, this AMU over here, it stands for the atomic mass unit. This U over here, it stands for the unified mass. U stands for the unified mass. And this D over here, it stands for Dalton. It stands for Dalton. So what I did, I took the carbon-12 atom. I divided the carbon-12 atom into 12 equal parts. After dividing the carbon-12 atom into 12 equal parts, I just took a small part over here. And my dear students, mass of this small part is just 1/12th of the mass of carbon-12 atom. And people, let me tell you, 1/12th of the mass of carbon-12 atom, from now onwards, we are going to call it either as 1 AMU, or we are going to call it as 1 U, or we are going to call it as 1 D. AMU stands for atomic mass unit, U stands for unified mass, and D stands for Dalton. D stands for Dalton. Please and please avoid writing anything in the chats. Focus on the session. Focus on the session. Right? Focus on the session. Now, my dear students, let me tell you one more thing over here. What scientists exactly did, they used a technique called as mass spectrometry. They used a technique called as mass spectrometry. With the help of this mass spectrometry, what scientists did, they calculated the mass of entire carbon-12 atom. Let me tell you, after using this technique of mass spectrometry, the mass of entire carbon-12 atom was found out to be 1.99 into 10 raised to the power minus 23 grams. After using the technique of mass spectrometry, what scientists exactly did? They calculated the mass of whole carbon-12 atom. And the mass of entire carbon-12 atom was found out to be how much? 1.99 into 10 raised power minus 23 grams. Now, if I ask you a question, since people, you know the mass of entire carbon-12 atom now, that is this much. How much is the mass of one carbon-12 atom? You know it now, it is 1.99 into 10 raised power minus 23 grams, right? If you divide this term by the number 12, right? What is the value which you'll be getting over here? The value will come out to be 1.66 into 10 raised power minus 24 grams. Now I'm asking you a question. Can you tell me whether this particular term, whether this is the mass of whole carbon-12 atom? Just say yes or no in the chats. Just say yes or no in the chats. Just say yes or no in the chats quickly. Just say yes or no in the chats. Is this the mass of whole carbon-12 atom? No, this is not the mass of whole carbon-12 atom. This is the mass of 1/12th part of the carbon. This is the mass of 1/12th part of the carbon. Or you can say, this particular term, it is the mass of this shaded part over here. It is the mass of this shaded part over here. And people, let me tell you one more thing. This 1.66 into 10 raised power minus 24, this can be also written as 1 divided by Avogadro's number. And I believe you already know the value of Avogadro's number. That is 6.022 into 10 raised power 23. So when you divide 1 by the Avogadro's number, you'll be getting the value exactly as 1.66 into 10 raised power minus 24. Okay? So, whatever I told you till now, I'm going to write every single thing in one statement. Whatever I told you till now, every single thing I'm going to write in the form of one simple statement. And the statement is like this. I'll write 1 AMU, which is what we call as 1 U, which is also what we call as 1 D. How did we define it? 1/12th of the mass of carbon-12 atom. 1/12th of the mass of carbon-12 atom. And my dear students, with the help of mass spectrometry, the mass of this carbon-12 atom was calculated as 1.99 into 10 raised power minus 23 grams. And later on, we divided this particular term by the number 12. The value came out to be 1.66 into 10 raised power minus 24 grams. And in terms of Avogadro's number, you are going to write it as 1 by NA, and the units are going to be in grams. This is the first statement which I would want you guys to remember from now onwards throughout one complete year. My dear students, this is the statement which I would want every one of you to remember from now onwards. This is the statement which I would want every one of you to remember from now onwards. 1 AMU, which is also called as 1 U, which is also called as 1 D. How did we define it? 1/12th of the mass of carbon-12 atom, right? Its value came out to be 1.66 into 10 raised power minus 24 grams, which is also equal to 1 divided by NA grams. 1 divided by Na grams. I believe this particular statement is clear to everyone. Yeah? Now people try to understand. Try to understand. Try to understand. Try to understand. See, people. The first statement which I'm marking over here, the statement is, I'm writing atomic mass of nitrogen. I'm writing a statement, atomic mass of nitrogen. If I ask you, first of all, what is the meaning of this term? Atomic mass of nitrogen means what? Atomic mass of nitrogen is nothing. It means that I am talking about the mass of one atom of nitrogen. It means that I am talking about the mass of one atom of nitrogen. Now, my dear students, try to understand carefully. Have you seen the periodic table? Yes, you would have seen the periodic table. On every element at the top, its atomic mass is written. So can you tell me what is written at the top of the nitrogen? You must be knowing it. At the top of the nitrogen, you'll find something like this, 14. And I'm writing AMU with it. Yeah? So my dear students, what is this 14 AMU over here? This 14 AMU, it is something which I call as the atomic mass of nitrogen. This is something which I call as the mass of one atom of nitrogen. This is something which I call as the mass of one atom of nitrogen. Now you tell me, can I break this 14 AMU as 14 multiplied by 1 AMU? I can do that. I can do that. My dear students, instead of 1 AMU, can't we write 1 by 12th of the mass of carbon-12 atom? Yes, we can do that too. My dear students, instead of 1 AMU, can't we write 1.66 into 10 raised power minus 24 grams? Yes, we can do that too. My dear students, instead of this 1 AMU, can't we write 1 divided by Avogadro's number in grams? Yes, we can do that too. Yeah. Now tell me the meaning of all these things over here. What is the meaning of all these things? I just wanted to calculate the atomic mass of nitrogen. I just wanted to calculate the mass of one atom of nitrogen. And my dear students, the mass of one atom of nitrogen came out to be how much? 14 AMU. Now what does it mean? It means that one atom of nitrogen is 14 times heavier than 1 AMU. Do you get it? One atom of nitrogen is 14 times heavier than 1/12 of the mass of carbon-12 atom. Yeah? Can I say this particular term, this is the mass of one nitrogen atom in grams? Yes, this is the mass of one nitrogen atom in grams. Even you can call this particular term also as the mass of one nitrogen atom in grams. Correct? Correct, people? Okay. Tell me one thing. If I mark a small question over here, calculate the mass of 10 oxygen atoms. Calculate the mass of 10 oxygen atoms. Number 1, in AMU. Number 2, in grams. You should be able to solve this question. It's very simple and basic. You should be able to solve this question. My dear students, how exactly you are going to solve it? See, first thing, we are supposed to calculate the mass of 10 oxygen atoms. If I ask you, what is the atomic mass of oxygen? If I ask you, what is the atomic mass of oxygen? You will say, it is nothing but 16 AMU. It is nothing but 16 AMU. What does that mean? That means one atom of oxygen is 16 times heavier than 1 AMU. Correct? It also means that one atom of oxygen is 16 times heavier than 1/12 of the mass of carbon-12 atom. Right? My dear students, instead of 1 AMU, we can write 1.66 into 10 raised power minus 24 grams. This is something which we already know. Yeah? Now. See, first thing, this is something which I am calling as atomic mass of oxygen. Or you can call it as the mass of one atom of oxygen in what? In AMU. This is the mass of one atom of oxygen in AMU. I'll say this is the mass of one atom of oxygen in grams. Imagine I have two atoms of oxygen. Imagine I have two atoms of oxygen. What will be the mass of two atoms of oxygen in AMU? Multiply this term with 2. What is the mass of 3 atoms of oxygen in AMU? Multiply by 3. What is the mass of 10 oxygen atoms in AMU? Multiply this term by 10. As simple as that. Right? Yeah? So what is going to be the answer to the first question? I will say the mass of 10 oxygen atoms in AMU will be, multiply this term by 10, the value comes out to be 160 AMU. 160 AMU is the mass of 10 oxygen atoms in grams. Okay? Sorry, in AMU. This is the mass of 10 oxygen atoms in AMU. Now, what is the mass of 10 oxygen atoms in grams? Well, the mass of one oxygen atom in grams is this much. So multiply this term by 10. So 16 multiplied by 10 comes out to be 160. So 160 multiplied by 1.66 into 10 raised power minus 24 grams. What is the meaning of this particular term? This is the mass of 10 oxygen atoms in grams. These were the two things which I was supposed to calculate, nothing else. Am I clear to everyone quickly in the chats? Am I clear to everyone, people? Am I clear to everyone? Quickly in the chats. Okay, one more thing. For example, I'm writing a statement over here. I'm writing a term atomic mass. Atomic mass of what? For example, atomic mass of sodium. What is the meaning of the term atomic mass of sodium, first of all? It means that I'm talking about the mass of one atom of sodium. My dear students, on the periodic table, if you would have seen sodium, on the top of sodium something is mentioned as 23, and I'm writing AMU with it. Correct? I'm writing AMU with it. Now, my dear students, this 23 AMU, you can break it as 23 multiplied by 1 AMU. Instead of 1 AMU, you can write 1 by 12th of the mass of carbon-12 atom. Instead of 1 AMU, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1 AMU, you can write 1 divided by Avogadro's number in grams. Right? So all the information about sodium you are writing over here. Yeah? See, I just wanted to know the atomic mass of sodium. I just wanted to know the mass of one atom of sodium. And people, the mass of one atom of sodium came out to be how much? 23 AMU. What does it mean? It means that one atom of sodium is 23 times heavier than what? One atom of sodium is 23 times heavier than 1 AMU. Right? Can I say one atom of sodium is 23 times heavier than 1 by 12th of the mass of carbon-12 atom? Absolutely. Can I say this is the mass of one sodium atom? This is the mass of one sodium atom in grams. Even this is also the mass of one sodium atom in grams. Correct? I believe it's clear to you. Now, people, if you analyze things properly, if I ask you what kind of information atomic mass is giving you, what kind of information atomic mass is giving you? My dear students, think logically. Can I say atomic mass gave me an idea? Atomic mass gave me an idea. What kind of idea? Atomic mass told me that one atom of nitrogen is 14 times heavier than 1 AMU. Atomic mass gave me an idea that one atom of oxygen is 16 times heavier than 1 AMU. Atomic mass only told me that one atom of sodium, that is 23 times heavier than 1 AMU. Correct? This all information, who is giving me? Atomic mass is giving me. So can I define atomic mass in a different way as well? Can I say atomic mass gives an information? Can I say atomic mass gives an information about how many times? About how many times an atom of an element is heavier than 1 AMU. Let me know once in the chats if this particular statement is clear to every one of you. I want the answers in the chats. Quickly, people. Let me know in the chats if this particular statement is clear to everyone. I would want yes or no in the chats from everyone, from everyone, from everyone. I want to know in the chats, yes or no in the chats. Quickly. Quickly, the chat should run continuously, guys. Quick, 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 quick. Quick. There should not be a single doubt. There should not be a single doubt throughout this particular journey of 1 year, yeah? Perfect, people. Perfect. Wonderful. Amazing. Now, there are a few more things which I would want to address over here, which you should know from now onwards, yeah? Which you should know from now onwards. Try to understand, people. Try to understand. My dear students, for example, I'm taking the element nitrogen over here. This is nitrogen. But if you think logically, I just wrote N. I did not write N2. I did not write N2. I just wrote N. So basically, I took nitrogen in which form? I took nitrogen in atomic form. So basically, I took nitrogen in atomic form. Now, my dear students, understand and remember. Related to nitrogen, I am going to write few things, few terminologies. The first term, I will be writing as 14 AMU. The second term, I'm only writing 14. I'm not writing any units with it. The third term, I'm writing 14 multiplied by 1 AMU. And instead of 1 AMU, I'm writing 1.66 into 10 raised power minus 24 grams. The first term which I wrote over here, I should be calling it from now onwards as the atomic mass of nitrogen. This is something which I will be calling as the atomic mass of nitrogen. Number one. The second term, without any unit, I will be calling it as the relative, atomic mass of nitrogen. Relative atomic mass of nitrogen, right? This third term, my dear students, I will be calling it as the actual mass. I will be calling it as the actual mass of nitrogen. So how many terms did I get over here? 3 terms. 1, when the unit is specified as AMU, that means the term is atomic mass. When there is no unit associated, this is the relative atomic mass, right? When you are multiplying with this number, that means you are talking about the actual mass. Now you tell me people. For example, I am taking the element X. Now, with respect to this X, I'm writing 3 terms. You tell me the meaning of these 3 terms which I'm going to write. First term, I'm writing M AMU. Second term, only and only I'm writing M. Third term, I'm writing M multiplied by 1.66 into 10 raised power minus 24 grams. What should I be calling the first term as? What should I be calling the first term as? Everyone in the chats. Everyone in the chats, people. What should I be calling the first term as? This is something which you will be calling as the atomic mass of X. Okay? This is something without the unit. You'll be calling it as the relative atomic mass of X. This particular term, you should be calling it as the actual mass of X. You should be calling it as the actual mass of X. I believe I'm clear to all watching me right now. Yeah? Am I clear? Say yes or no in the chats. Everyone. Yeah? I believe all the things are clear till here. Let the chats continuously run. Perfect. Wonderful. So, I believe the first terminology which I have discussed with you, The basic terminology, atomic mass. I believe atomic mass term is clear to everyone. Yeah? Guys, one thing which I would want you guys to do for today only. One thing which I would want you guys to do. What is that? Please and please, remember the atomic masses of first 30 elements. From hydrogen till zinc. From hydrogen till zinc. Please and please remember their atomic masses. Please and please remember their atomic masses. Okay? This is going to be just your homework for today. Remember the atomic masses from hydrogen till zinc. That means first 30 elements. This is something which you guys are going to do. This is something which you guys are going to do. Okay? Perfect. My dear students, let's move on. Let's move on to one more terminology, which you call as molecular mass. Which you call as molecular mass. If I ask you, how do we define the term molecular mass? You should be in a position to define the term molecular mass. This is again one basic terminology. This is again basic stuff. This is complete basic stuff. Okay? What is the molecular mass? Simple. Molecular mass, in basic terminologies, I can define it as the mass of one molecule. What does that mean? Mass of one molecule. Or it is defined as the sum of atomic masses of all the atoms, the sum of atomic masses of all the atoms present in a molecule. Now, what does it mean? Let's try to understand it properly and clearly. See guys, for example, I'm taking water into consideration. Let's say I'm taking water into consideration. Now, I'm asking you, what is the molecular mass of water? For example, this is the general question which I'm asking you. What is the molecular mass of water? So what does that mean? What am I asking you? What am I asking you exactly? I'm asking you about the mass of one molecule of water. I'm asking you about the mass of one molecule of water. How do you calculate the mass of one molecule of water? Mass of one molecule of water is what you call as molecular mass of water. How do you calculate it? Simple. Sum of atomic masses. In your water, there are two elements, hydrogen and oxygen. If I ask you, what is the atomic mass of hydrogen? It is 1 AMU. How many hydrogen atoms do you see here? 2 hydrogen atoms. Right? Plus, what is the atomic mass of oxygen? 16 AMU. How many oxygen atoms do you see here? 1. The value comes out to be 18. 18. Now, either you write AMU, or you write U, or you write D. Choice is all yours. But remember, preferably in case of molecules, what do we write? Preferably in case of molecules, we write U. Right? Preferably, we write U. Correct, people? Now. This 18U over here, I can break it as 18 multiplied by 1U. Yes, I can do that. Instead of 1U, I can write 1/12 of the mass of carbon-12 atom. Absolutely, I can do that. Again, instead of 1U, I can write 1.66 into 10 raised power minus 24 grams, right? Or instead of 1U, I can write 1 divided by Na grams. Now, tell me the meaning of all these things. Tell me the meaning of all these things. I wanted to calculate the molecular mass of water. I wanted to calculate the mass of one molecule of water. The mass of one molecule of water came out to be 18U. That means one molecule of water is 18 times heavier than 1U. One molecule of water is 18 times heavier than 1/12 of the mass of carbon-12 atom. Right? Can I say this is the mass of one water molecule in grams? Yes. Even this is the mass of one water molecule in grams. This is the mass of one water molecule in U. Simple. As simple as that. Right? Right, people? For example, I'm asking you to calculate the molecular mass of NH3, ammonia. What does that mean? That means I'm asking you to calculate the mass of one molecule of ammonia. I'm asking you to calculate the mass of one molecule of ammonia. How do you calculate it? Sum of atomic masses. Sum of atomic masses. What is the atomic mass of nitrogen? 14 AMU. How many nitrogen atoms? One nitrogen atom. What is the mass? What is the atomic mass of hydrogen? 1 AMU. 3 hydrogen atoms. The value comes out to be 17U. The 17U can be broken down as 17 multiplied by 1U, right? Instead of this 1U, what can you write? Instead of 1U, you can write 1 by 12th of the mass of carbon-12 atom. Instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1U, you can write 1 divided by Na. The units are going to be in grams. Now, people, if I ask you what is the meaning of all these things, what is the meaning of all these things? Tell me that. I wanted to calculate the molecular mass of NH3. I wanted to calculate the mass of one molecule of NH3. And the mass of one molecule of NH3 came out to be 17U. That means one molecule of NH3 is 17 times heavier than 1U. One molecule of NH3 is 17 times heavier than 1 by 12th of the mass of carbon-12 atom. Can I say this is the mass of one ammonia molecule in grams? Even this is also the mass of one ammonia molecule in grams. As simple as that. Right? As simple as that. For example, I'm taking glucose into consideration. C6H12O6. If I ask you what is the molecular mass of glucose, first of all, what am I asking you? I'm asking you to calculate the mass of one molecule of glucose, right? How do you do that? How do you do that? How do you calculate the mass of one molecule of glucose? Just calculate the sum of atomic masses. Start with carbon. What is the atomic mass of carbon? 12 AMU. How many carbon atoms? 6. Right? Hydrogen, 1 AMU. How many hydrogen atoms? 12. Oxygen, 16 AMU. How many oxygen atoms? 6. When you solve this, the value comes out to be 180. I can write AMU, I can write U, I can write D. But preferably, I'll be writing U over here. This 180U can be broken down as 180 multiplied by 1U. Now, instead of 1U, you can write 1 by 12th of the mass of carbon-12 atom. Now, instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1U, you can write 1 divided by Avogadro's number in grams. Tell me the meaning of all these things over here. Tell me the meaning of all these things over here. My dear students, I wanted to calculate the molecular mass of glucose. That means I wanted to calculate the mass of one molecule of glucose. The mass of one molecule of glucose came out to be 180U. One molecule of glucose is 180 times heavier than 1U. One molecule of glucose is 180 times heavier than 1 by 12th of the mass of carbon-12 atom. This is the mass of one molecule of glucose in grams. Even this is the mass of one molecule of glucose in grams. If I'm clear, let me know once in the chats. Quickly. Yeah? Quickly, people, quickly. I want the chats to run. I want the chats to run. Perfect. Wonderful. Amazing. Guys, this has to be the Josh throughout the year, okay? This is not something which you'll show for 1 week or 1 day or 3 days. It has to be throughout the year. It has to be throughout the year. Just remember that. Just remember that. Yeah? I've seen people starting their preparation with high Josh and eventually after a week, they are gone. They're over. You're not supposed to do that. You are not supposed to do that. Yeah? Perfect. Let's move on. Let's move on, people. Okay, one thing which I would want to address over here. If I ask you what kind of information molecular mass is giving us, if I ask you what kind of information molecular mass is giving us, try to understand. Molecular mass gave us information about what? About water. Molecular mass told you that one molecule of water is 18 times heavier than 1U. Molecular mass told you that one molecule of ammonia is 17 times heavier than 1U. Molecular mass told you that one molecule of glucose is 180 times heavier than 1U. So what kind of information this molecular mass is giving us? Can I say molecular mass? Can I say molecular mass? gives an information, molecular mass gives an information about how many times, a molecule is heavier than, heavier than what? Heavier than 1U, right? I believe this particular statement will be absolutely clear to every one of you. Now, people, one important thing which I'm going to mention over here. See, over here, I'm taking, for example, N2. Over here, for example, I'm taking N2. So I've taken nitrogen, yeah? I've taken nitrogen. But this nitrogen here, I have taken in which form? Atomic form or molecular form? This nitrogen I have taken in molecular form. This nitrogen I have taken in molecular form. Correct? Molecular form. Now, my dear students, I'm going to write few things about this N2. And you are going to let me know in the chats about the meaning of those terms. The first term I'm writing 14 multiplied by 2 is 28, and I'm writing U. Then I'm writing only 28. Then I'm writing 28 multiplied by 1.66 into 10 raised to the power minus 24 grams. Can you let me know the meaning of these three terms quickly? Quickly, people, quickly. This particular term I will be calling as the molecular mass of nitrogen. Molecular mass of nitrogen. This particular term I'll be calling as relative atomic or relative molecular. I'll be calling this as the relative molecular mass of nitrogen. Right? This particular term, what you should be calling it? You will be calling it as the actual mass. But is this the actual mass of N or actual mass of N2? This is the actual mass of N2. Correct, people? Correct? Let's try to differentiate all the terms. Whatever things we have discussed till now, let's try to differentiate. Right here I'm writing O, and over here I'm writing O2. What is the difference between these two? My dear students, it's very simple. Here oxygen I have taken in atomic form. Here oxygen I have taken in atomic form. Oxygen here I have taken in molecular form. This is the difference. Atomic form, molecular form. Now, people, you tell me the things. First thing, related to oxygen. First thing, I'm writing 16 AMU. Then I'm only writing 16. At the end, I'm writing 16 multiplied by 1.66 into 10 raised power minus 24 grams. Here, I'm first writing 32U. Then I'm writing 32. Then I'm writing 32 multiplied by 1.66 into 10 raised power minus 24 grams. I want you to tell me the meaning of all these things. The first term, what do I call this as? Quickly in the chats, what do I call this as? What do I call this as? Quickly. In the chats, I call this as? This is the atomic mass of oxygen. What about this one? Relative atomic mass of oxygen. What about this one? Actual mass of O. Actual mass of O. What about this one? Molecular mass. Molecular mass of oxygen. What about this term? Relative molecular mass of oxygen. What about this term? Actual mass of what? Actual mass of O2. I hope you can easily differentiate all these terms from now onwards. Now, people, have a look. Have a look. Try to understand. Whatever things I've told you, let me quickly summarize them. Over here, oxygen is in atomic form. Right? This particular term is the atomic mass of oxygen. That means this is the mass of one atom of oxygen. This means that one atom of oxygen is 16 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1/12th of the mass of carbon-12 atom. The second term, you call it as the relative atomic mass. The third term, you call this as the actual mass of O. That means this is the mass of one oxygen atom in grams. Go to this statement. 32U. This is the molecular mass of oxygen. This is the mass of one molecule of oxygen. One molecule of oxygen is 32 times heavier than 1U. One molecule of oxygen is 32 times heavier than 1/12th of the mass of carbon-12 atom. The next term, that is the relative molecular mass of oxygen. The next term, that is the actual mass of O2. That means this is the mass of one molecule of O2 in grams. I believe all these things are absolutely clear to every one of you. Shama is saying why only carbon is taken as a reference. Before carbon, oxygen was taken. Before oxygen, hydrogen was taken, right? So whatever is irrelevant, let's not discuss the irrelevant stuff. When you talk about your competitive examination, they will never ask you why carbon was chosen as the why carbon 12 element was chosen to make the standard. They'll never ask you this question. Why do you want to waste your energy, time, as well as memory by memorizing these things, right? So please and please, whatever I tell you, just remember that, okay? That's more than sufficient. Do not use your brain, okay? Perfect. Let's move on. Let's move on, people. I believe all the things are clear till here. Now, you guys are going to solve one simple, one basic question with me. One simple and basic question. Calculate the mass of 100 molecules. Calculate the mass of 100 molecules of H2SO4. Number 1. In U. Number 2. In grams. Will you be able to solve this question? Will you be able to solve this question? Will you be able to solve this question? Quickly, people. First of all, if I talk about H2SO4 in particular, can you calculate the molecular mass of H2SO4? You can do that. Hydrogen, atomic mass is 1. There are 2 hydrogen atoms. Sulfur, atomic mass 32, 1 sulfur atom. Oxygen, atomic mass 16, 4 oxygen atoms. When you solve this value, comes out to be 98U. What is this 98U? This is the mass of one molecule of H2SO4 in U. This is the mass of one molecule of H2SO4 in U. So what will be the mass of 100 molecules of H2SO4? Multiply this term by 100. So it is just going to be 9800U. This is the mass of 100 molecules of H2SO4 in U. Right? Now, what is the mass of 100 molecules of H2SO4 in grams? For that, you should know what is the mass of one molecule of H2SO4 in grams. It is 98 multiplied by 1.66 into 10 raised per minus 24 grams. This is the mass of one molecule of H2SO4 in grams. What do I need? I need the mass of 100 molecules of H2SO4 in grams. So multiply this term with 100. So it comes out to be 98 into 1.66 into 10 raised per minus 22 grams. This is the mass of 100 molecules of H2SO4 in grams. As simple as that. I just multiplied this term with 100, right? 100 into 10 raised per minus 24 comes out to be 10 raised per minus 22. I believe I'm clear. Yeah? Okay? Perfect. Now, since I discussed two terms with you, one is atomic mass, one is molecular mass. Now, people, what kind of questions can be asked out of these two terms? Yeah? What kind of questions can be asked out of these two terms? The first question that can be asked, like this. Okay. Before solving the question, there is one thing which I would want to add over here, and please take a note of this particular statement which I'm writing. After that, I'll give you the question. After that, I will give you the question. But before that, take a note of the statement. Statement is very, very, very important. Statement is like this. On changing the standard. On changing the standard. First of all, what is our standard? What standard we have fixed? We have fixed the standard as 1 AMU, and 1 AMU is equal to 1 by 12th of mass of carbon 12 atom. Now, my dear students, if we change the standard, if 1 AMU is defined as 1/6 of the mass of carbon 12 atom, if 1 AMU is defined as 1/24th of the mass of carbon 12 atom. So in short, if we change the standard, remember, on changing the standard, actual mass of the substance remains unchanged. So whenever you are going to change the standard, it is going to be the actual mass of the substance which is not going to change. Take a note of this, right? Take a note of this. This statement is super, super, super important, right? When you change the standard, right? It is the actual mass of the substance which is never going to change. Never going to change. Let me give you the question so that you'll understand all these things properly. Okay? One simple question so that you will analyze and remember things. The question is like this. The question is like this. If 1U is defined as, if 1U is defined as 1 by 24th of, if 1U is defined as 1 by 24th of the mass of carbon-12 atom. 1 by 24th of the mass of carbon-12 atom. Then calculate the molecular mass, of NH3 on new scale. This is the first question. Second thing which I'm asking over here. Also calculate the actual mass. Of NH3. Okay, this is the question, guys. This is the first question which can be asked. Let's try to understand how this sort of equation is to be solved. My dear students, try to understand carefully. How did we define 1U? You should remember that. How did we define 1U? If you remember, we defined 1U as 1 by 12th. We defined 1U as 1 by 12th of the mass of carbon-12 atom. This is how we have defined 1U. As per the question, they are defining 1U in a different way. They are defining 1U as 1 by 24th of the mass of carbon-12 atom. Right? So, as per the question, they are defining 1U in a different way, which I'm calling as 1U dash. They are defining it as 1 by 24th of the mass of carbon-12 atom. Okay? They are defining 1U in this way. First of all, this is the scale which we have chosen. I call this as the conventional scale, or you can call it directly as old scale. This is the scale which we have chosen. This is the scale that is given to us as per the question. So this is our new scale. As per the question, what are we supposed to calculate? We are supposed to calculate the molecular mass of NH3 as per new scale. We are going to calculate the molecular mass of NH3 as per new scale. We are going to calculate the molecular mass of NH3 as per U dash, not as per U. Yeah, as per U dash, not as per U. How do we approach to these sort of questions? My dear students, the first thing, call this as equation 1, call this as equation 2. First thing, divide these two equations. Either divide 1 with 2 or 2 with 1. Choice is yours. For example, I'm dividing 1 with 2. If I divide 1 with 2, then it's going to be U divided by U dash. U divided by U dash is equal to this mass of carbon-12 cancel. In the numerator, you have got 1 by 12. In the denominator, you have got 1 by 24. So therefore, U divided by U dash is equal to 2. And therefore, U is equal to 2 times U dash. So, whenever you see this sort of a question, the first thing which you will be doing from now onwards, you will be getting the relation between U and U dash. You will be getting the relation between old U and new U. That is the first thing which you'll be doing always. Okay? Got the relation between U and U dash. Once you are done with this, now people, now, as per the question, what are we supposed to calculate? We are supposed to calculate the molecular mass of NH3. As per which scale? As per new scale. Now, do we know the molecular mass of NH3 as per old scale? As per U? Yes, we calculated few minutes back. It came out to be 17U, if you remember. This was the molecular mass of NH3 as per our scale, which we have chosen. But do we have to calculate the molecular mass of NH3 as per our scale? No. As per the new scale. Right? As per the new scale. So people, this 17u, can I break it as 17 multiplied by 1u? Yes, I broke it as 17 multiplied by 1u. Instead of 1u, can I write 2 times u dash? Yes, instead of 1u, I can write 2 times u dash. The value comes out to be 34u dash. So let me tell you, this is the molecular mass of NH3 as per which scale? Old scale or new scale? This is the molecular mass of NH3 as per your new scale, as per your u dash. I believe this is clear. This was the first thing which I was supposed to calculate. What about the second thing? Second thing, calculate the actual mass. Yeah, calculate the actual mass of NH3. I told you already, on changing the scale, it is the actual mass of the substance that never changes. Whatever was the actual mass of NH3 earlier, now also the actual mass of NH3 is going to be the same, right? So people, the second question, actual mass of NH3. Actual mass of NH3 earlier was 17 multiplied by 1.66 into 10 raised power minus 24 grams. Now also it's going to remain the same. No change at all. No change at all. I believe this is clear. I believe this is clear. I believe this is clear. Yeah? I believe this is clear. Arshid is asking a question. What is the question? If 1u is defined as 1/6 of the mass of carbon to an atom, then calculate the molecular mass of NH3 on the new scale. The answer is going to be 8.5 u dash. Yeah? I believe this sort of question, guys, you can easily solve from now on. Okay? Let me give you one more similar sort of question so that you can understand it properly. The question is like this. If 1u is defined as 1 by 36th of 1/36th of the mass of carbon to an atom. Calculate the molecular mass of glucose C6H12O6 on new scale. Can you give it a try? Can you solve this on your own? Can you solve this question on your own? Can you solve this on your own? Quickly. Quickly, people. Quickly, let me know the answer in the chats. I want everyone to solve this first. I want everyone to solve this. This question has to be solved in less than 20 seconds. You should be able to solve this question in less than 20 seconds. Less than 20 seconds. Less than 20 seconds. Less than 20 seconds, people. All right. Majority has already given the answer and you guys are absolutely correct. Let me show it to you. As per the question, how do we define 1u? I'll be super fast now. 1u is defined as 1/12th of the mass of carbon to an atom. This is how we have defined 1u. I'm calling this as old scale. As per the question, how they are defining 1u? 1u, they are defining as 1/36th of the mass of carbon to an atom. I'm calling this as equation 2. The first step always, divide the two equations. First step always, divide the two equations. Equation 1 by equation 2. So it's going to be u divided by u dash. U divided by u dash is equal to. U divided by u dash is equal to this term cancel. 36 goes up, right? So it's basically 1/12 and this 1/36. So what did we get over here? U by u dash is equal to 3. Therefore, u is nothing but 3 times u dash. So I got the relation between u and u dash. That's my first step always. Now, second thing. What is the molecular mass of glucose? What is the molecular mass of glucose as per u? As per u, we have already calculated as 180 u. But we are not supposed to write the answer in terms of u. We are supposed to write the answer in terms of u dash. So I'll be breaking it as 180 multiplied by 1u. And instead of 1u, I'm just going to write 3 times u dash. So it's going to be 540 u dash. Got it? Done and dusted? Okay. What about its actual mass? Actual mass is going to remain the same. 180 multiplied by 1.66 into 10 raised per minus 24 grams. Actual mass does not change on changing the scale. I hope I'm clear to everyone. If I'm clear, let me know once in the chats with some fire emojis. Everyone, people. Everyone in the chats. Everyone in the chats. Everyone in the chats. Perfect, guys. Perfect, perfect, perfect. Now comes the third and one of the most important terms when you talk about the mole concept. What is it? It is molar mass. Now, people, how do we exactly define the term molar mass? You should know it first thing. You should know it first. Molar mass is basically defined as the mass of 1 mole of a substance. It is defined as the mass of 1 mole of the substance. Second thing, it is expressed in grams per mole, or you can directly say it is expressed in grams. Now, let's try to understand what this molar mass is all about. Let's try to understand the significance of the molar mass. Let's try to understand the meaning of the molar mass. Before making you understand the meaning of the molar mass, I believe all of you remember our statement which I gave you already. What was that? That was 1 AMU is equal to 1 U is equal to 1 D is defined as 1 by 12th of the mass of carbon-12 atom is equal to 1.66 into 10 raised power minus 24 grams is also equal to 1 divided by Na grams. I believe you all remember this particular statement because this statement I use over here. I'm going to use over here. How come I'm going to use this statement? You'll get the idea in some time. But before that, my dear students, what is meant by the term 1 mole of substance? If I write 1 mole substance, what is meant by that? 1 mole of the substance. What is a mole? Mole is a unit, like kg, like liter, like etc., whatever. Mole is just a unit, right? It is just 1 mole substance, 1 mole of any substance contains 6.022 into 10 raised power 23 particles of the substance. 1 mole of the substance, 1 mole of any substance basically contains what? 6.022 into 10 raised power 23 particles of the substance. For example, if I say I have got 1 mole carbon, what does that mean? First of all, try to understand. Carbon here is in atomic form, right? 1 mole carbon means that I have got 6.022 into 10 raised power 23 carbon atoms. Yes, as simple as that. Correct? If I say that I have got 1 mole water, water here is in molecular form, right? 1 mole water, that means I have got 6.022 into 10 raised power 23 water molecules. Correct? If I say I have got 1 mole iron, what does that mean? I've got 6.022 into 10 raised power 23 iron atoms. So basically 1 mole of the substance means what? 1 mole of substance means I have got 6.022 into 10 raised power 23 particles of the substance. Now people, look at the definition. What is molar mass? How do you define the molar mass of the substance? How do you define the molar mass of the substance? Molar mass is defined as the mass of 1 mole of the substance. Either you say it is defined as the mass of 1 mole of the substance, or you can say it is defined as the mass of 6.022 into 10 raised power 23 particles of the substance. Right? As simple as that. As simple as that. My dear students, try to understand. Try to understand very carefully what exactly I'm going to tell you. Say, for example, if I ask you, what is molar mass of carbon? If I ask you what is molar mass of carbon, what does that mean? What does that mean? Molar mass of carbon means I am talking about the mass of 1 mole of carbon. Molar mass of carbon means that I'm talking about the mass of 1 mole carbon. Molar mass of carbon means I'm talking about the mass of 6.022 into 10 raised power 23 atoms of carbon. Right? Right? Simple. Now, people, if I ask you, what is the molar mass of water? Molar mass of water, what does that mean? That means I'm talking about the mass of 1 mole water. I'm talking about the mass of 6.022 into 10 raised power 23 water molecules. Yeah? If I ask you, what is the molar mass of this marker? What is the molar mass of this marker? What am I asking you? I'm asking you the mass of 1 mole marker. I'm asking you the mass of 6.022 into 10 raised power 23 markers. Yeah? Simple? Now, if you understood this, let's try to get into the details. Let's try to get into the details, guys. The first statement which I'm writing a statement. Molar mass of oxygen. Molar mass of oxygen. What does it mean? First of all, try to understand. Oxygen here is in atomic form. Oxygen here is in atomic form. So molar mass of oxygen, what does it mean? Molar mass of oxygen means that I am talking about the mass of 1 mole of oxygen. I'm talking about the mass of 1 mole of oxygen, yeah? I'm talking about the mass of 1 mole of oxygen. Now, my dear students, tell me one thing. 1 mole of oxygen means what? 6.022 into 10 raised power 23 oxygen atoms, right? So, I can say, instead of mass of 1 mole of oxygen, I can write mass of 6.022 into 10 raised power 23 oxygen atoms. Yes, I can write like this. I can say it in this way. Mass of 6.022 into 10 raised power 23 oxygen atoms. So that is basically mass of 1 mole of oxygen. Correct? Now, people, how many oxygen atoms do you see here? Mass of Na oxygen atoms. So how many oxygen atoms do we have? Na oxygen atoms, right? How do you calculate the mass of Na oxygen atoms? How do you calculate the mass of Na oxygen atoms? My dear students, in order to calculate the mass of Na oxygen atoms, I'll just do one thing. I'll first try to calculate mass of 1 oxygen atom. I'll just try to calculate mass of 1 oxygen atom and then multiply that with Avogadro's number. As simple as that. Yeah? I'll just calculate mass of 1 oxygen atom, multiply that with Avogadro's number. I will be getting the mass of 6.022 into 10 raised power 23 oxygen atoms. That means I will be getting the mass of 1 mole of oxygen. That means I'm getting the molar mass of oxygen. As simple as that. Yeah? As simple as that. Now, people, tell me just one thing. What about this term? Mass of 1 oxygen atom. What does it mean? Mass of 1 oxygen atom means the atomic mass of oxygen. How much that is? That is 16 AMU. Right? Multiplied by what? Multiplied by Avogadro's number. Now tell me one thing. Can I break this 16 AMU as 16 multiplied by 1 AMU? Yes, I can do that. Multiplied by Na. Now already we know 1 AMU is nothing. 1 AMU is 1 by Na grams. Right? 1 AMU is nothing. 1 AMU is 1 by Na grams. 1 AMU is 1 by Na grams. We know it already. Can I say this Na got cancelled? The value came out to be how much? The value came out to be 16 grams. So what is the 16 grams here now? Is this the mass of 1 atom of oxygen? No. Is this the mass of 1 molecule of oxygen? No. Is this the mass of 1 mole of oxygen? Yes. Is this the mass of 6.022 into 10 raised power 23 oxygen atoms? Absolutely yes. So I should be calling this as the molar mass of oxygen. The molar mass of oxygen. Tell me, people. Is oxygen here in atomic form or molecular form? We have taken oxygen in atomic form. So remember, instead of molar mass, you can use the term gram atomic mass as well. You can use the term gram atomic mass of oxygen as well. Either you call it as the molar mass of oxygen or you can call it as the gram atomic mass of oxygen. The choice is all yours. Now guys, if you clearly have a look on certain things. Understand. What is the atomic mass of oxygen? Atomic mass of oxygen was 16 AMU. What is the molar mass of oxygen? Molar mass of oxygen is 16 grams. Yeah? Atomic mass of oxygen is 16 AMU. Molar mass of oxygen is 16 grams. So, where the difference lies? Where the difference lies? Difference is not in the magnitude. Difference lies in the units. Right? Difference lies in the units. When we talk about the atomic mass of element, the units are to be in AMU. When we talk about the molar mass of the substance, units are to be in grams, nothing else. Right? So can I say, in order to convert atomic mass into molar mass, in order to convert atomic mass into molar mass, do I have to change the magnitude? No, I just have to change the units. Instead of AMU, I just need to write what? Instead of AMU, I just need to write grams, nothing else. Yeah? Perfect, guys? Yeah? I believe I'm clear. Now try to understand. Try to understand, people. Let me quickly summarize all the things in one go now. Let me quickly summarize all the things in one go now. Here I'm writing N. Here I'm writing N2. So first term, I'm writing 14 AMU. Second term, I'm only writing 14. Third term, it's 14 multiplied by 1.66 into 10 raised power minus 24 grams. Next term, instead of 14 AMU, I'm only writing 14 grams. Talk here. N2. First, I'm writing 28 U. Second, I'm writing 28. Third, I'm writing 28 multiplied by 1.66 into 10 raised power minus 24 grams. Next, instead of 28 U, I'm only writing 28 grams. Tell me the meaning of all these things now. Tell me the meaning of all these things now. Tell me the meaning of all these things now. See, guys, first of all, here nitrogen is in which form? Nitrogen here is in atomic form. Right? Here nitrogen is in which form? It is in molecular form. It is in molecular form. Now tell me the meaning of all these things now. 14 AMU. It is the atomic mass of nitrogen. Right? I'll say this is the mass of one atom of nitrogen. This is the mass of one atom of nitrogen in AMU. Correct? What do I call this term as? This is the relative atomic mass of nitrogen. Relative atomic mass of nitrogen. What about this term? You call this as the actual mass of N. Actual mass of nitrogen. Or you can say this is the mass of one atom of nitrogen in grams. Mass of one atom of nitrogen in what? In grams. What about this particular term? This particular term. This is something which you will be calling as the molar mass of N. Molar mass of nitrogen. Or you can call this as the gram atomic mass of nitrogen. Gram atomic mass of nitrogen. What does that mean? That means this particular term, this is the mass of 1 mole of N. This is the mass of 1 mole of N. Or you can say this is the mass of 6.022 into 10 raised power 23 atoms of N. Okay? I hope this is clear. I hope this is clear. Now talk about this one. Talk about this one. 28U. What is it? It is the molecular mass of nitrogen. That means it is the mass of one molecule of nitrogen. In what? In U. Mass of one molecule of nitrogen in U. What about this thing? It is the relative molecular mass of nitrogen. What about this thing? This is the actual mass of N2. Right? Or you can say this is the mass of one molecule. This is the mass of one molecule of what? Of N2. In what? In grams. In grams. What about this term? What do I call this as? This was 28U. Instead of 28U, I'm only writing 28 grams. I'm not changing the magnitude. I'm just changing the units. So what is it? It is the molar mass of nitrogen. It is the molar mass of N2. Or should I be calling it as gram atomic mass or gram molecular mass? You will be calling this as gram molecular mass of nitrogen. You will be calling it as the gram molecular mass of nitrogen. Or I should be calling it as the mass of 1 mole of N2. Mass of 1 mole of N2. Or I can call it as the mass of 6.022 into 10 raised power 23 nitrogen molecule. Correct? I hope all these terms are absolutely clear to every one of you. If yes, let me know once in the chats quickly. Let me know in the chats quickly. Let me know in the chats quickly. Everyone. All the things are absolutely clear? Yeah? Guys, chats so run. Yeah? You're making the chats to crawl. I want the chats to run. I want the chats to run. All right. So, the topics which we discussed till now. Okay, let's try to solve the questions based on those topics. But, before solving the questions, one thing, one statement which you take a note of. One statement which you guys are going to take a note of. Take a note of one statement. My dear students, from now onwards, if you are supposed to calculate the molar mass of substance, if you are supposed to calculate the molar mass of any substance, first of all, you know the definition, you know its meaning. Molar mass of substance means mass of 1 mole of substance. Mass of 6.022 into 10 raised power 23 particles of the substance. Yeah? So, how do you calculate the mass of those 6.022 into 10 raised power 23 particles? What you will be doing? You will be calculating the mass of one particle. You will be calculating the mass of one particle of the substance in grams. And then you'll be multiplying that with the Avogadro's number. As simple as that. As simple as that. As simple as that. Molar mass of the substance, that means mass of 1 mole of the substance, that means mass of 6.022 into 10 raised power 23 particles of the substance, that means you just calculate mass of one particle, multiply that with Avogadro's number, you will be getting the mass of 6.022 into 10 raised power 23 particles of the substance. So in short, you are getting the molar mass of the substance. Yeah? I hope this is clear. I hope this statement is clear. Tell me the answer of this question. I'm writing the question. The mass of one atom of X. You have got an element X, right? The mass of one atom of element X is 4 into 10 raised power minus 23 grams. 4 into 10 raised power minus 23 grams. Identify the element X. I'm giving you the options. First option is fluorine. Second option is carbon. Third option is magnesium. Fourth option is none of the above. What do you think is the answer of this question? I want answer from everyone. I want answer from everyone. I want answer from everyone. Quick. Quickly, people. Quickly. Everyone. Yes, everyone. See, guys, it's very much simple. Yes, absolutely. All of you give the correct answer. It's going to be magnesium. Why is it going to be magnesium? How come magnesium? Try to understand. As per the question, the mass of one atom of element X is given, right? If the mass of one atom is given, can't you calculate molar mass of X? Molar mass of X, as per this formula, molar mass of substance is equal to mass of one particle multiplied by Avogadro's number. So molar mass of X means mass of one atom of X. Mass of one atom of X in grams. Multiply this thing with Avogadro's number. Right? Simple and basic. Tell me one thing. What is the mass of one atom of X? It is 4 into 10 raised power minus 23 grams. And multiply it with Avogadro's number, approximately 6 into 10 raised power 23. So this term cancel. 6 fours are 24. The value came out to be 24 grams. So molar mass of element X is coming out to be 24 grams. If molar mass of element is coming out to be 24 grams, that means if molar mass of element is coming out to be 24 grams, that means what will be the atomic mass of element? Do I have to change the magnitude or just unit? I just have to change the unit. Instead of 24 grams, I'll write 24 AMU. This is the atomic mass of element X. This is the atomic mass of element X. Now, which element among the following has got the atomic mass of 24 AMU? It is magnesium, which has got the atomic mass of 24 AMU. Yeah, you know it. You know it, people. Right? Am I clear? Am I clear? Simple. The mass of one atom of X was given. Mass of one atom of X was given. So I multiplied the mass of one atom of X with the Avogadro's number. I multiplied the mass of one atom of X with the Avogadro's number. What did I get? I got the molar mass of X. I got the molar mass of X. If you got the molar mass, convert the molar mass into atomic mass. How? You're not supposed to change the magnitude. You'll keep the magnitude same. It is just unit is to be changed. Instead of grams, write AMU. So atomic mass of X came out to be 24 AMU. If atomic mass of X is 24, which element among the three elements has got the atomic mass of 24? That is magnesium. You know it. So it's done and dusted, right? It is done and dusted. Okay. Tell me the answer of this question. One simple question I'm writing. Calculate the molar mass of electron. Calculate the molar mass of electron. Can you do it? Calculate the molar mass of electron. Simple formula. I told you a few minutes back. Molar mass of electron is nothing but mass of one electron. First, I'll calculate the mass of one electron. And later on, I'll multiply it with Avogadro's number. We are done. So mass of one electron is nothing but, you know it, 9.1 into 10 raised power minus 28 grams. And later on, I'll multiply it with Avogadro's number approximately 6 into 10 raised power 23. So this is 6 ones are 6, 6 nines are 54. So 54.6 multiplied by 10 raised power this, 10 raised power this. So 10 raised power minus 5 grams. Right? Simple. This is the molar mass of electron. This is the mass of 1 mole of electron. This is the mass of 6.022 into 10 raised power 23 electrons. How did I calculate it? First, I wrote the mass of 1 electron. Multiply it with Avogadro's number. You got the mass of 6.022 into 10 raised power 23 electrons, which means you got the mass of 1 mole electrons, which means that you got the molar mass of electron, right? Simple. Am I clear? Am I clear, people? Am I clear, people? Let me know in the chats. Everyone. Everyone. Let me know in the chats quickly. Let me know in the chats quickly. Everyone. Everyone means everyone. Everyone means everyone. Sir, how 9.1, guys? Mass of electron is equal to 9.1 into 10 raised power minus 28 grams, right? This is something at least you should know. Something which we study in class 9th, class 7th, right? Right, people? Who's this no man, no man? What are you talking, bro? Are you out of your senses or what? What are you talking about? Are you talking something about you? Bro, this is not the channel to be spammed. You need to get the hell out of here. I'm blocking you. You're blocked. Okay. One more question, people. One more question. Suppose we have got two elements x and y. Suppose we have got two elements x and y. Suppose elements x and y combines. Combines to form two compounds. Suppose elements x and y combines to form two compounds. xy2 and x3y2 and x3y2. If 0.1 mole x3y2 or if 0.1 mole xy2 weighs 10 grams and 0.05 mole and 0.05 mole x3y2 weighs 9 grams. Calculate the atomic mass of x and y. Okay, this is the question which is going to be your homework question, okay, which you will try to solve, and the next class, you will let me know the answer of this question, right? If you were unable to solve this question, then we'll start the next class with this question itself. But tell me one thing. Is every single thing clear till here? Is every single thing clear till here? Whatever I've discussed with you till now? Whatever I discussed with you till now, is everything clear? Someone is saying mass of electron is wrong. Mass of electron in grams is same, 9.1 into 10 raised per minus 28 grams, right? You are telling 10 raised per minus 31, that is kg. I hope every single thing is clear, done and dusted, right? So people, right after this session, I would want you guys express the genuine feelings of this particular session in the comments, not in the chats, okay? So that everyone knows what the Phoenix NEET 2.0 English batch exactly is all about, right? Perfect, guys. And all the students who could not enroll into the batch yet, this was the first session of the Phoenix 2.0 NEET English batch, which we took on YouTube. Now, all the other sessions will happen on the Unacademy platform. If you want to be the part of the Phoenix 2.0 NEET English batch, which has started today, right? My dear students, there's a link in the description box of the video. Click on that link right now. Get enrolled into the batch right now and be the part of the live classes from tomorrow itself on the Unacademy platform. In the batch, we are completing the whole syllabus of physics, chemistry, biology in just 6 months. Every chapter will be done from the basics, from the scratch. All the theory, all the problem patterns included in the chapter, they'll be done and dusted in detail. Once we are done with the syllabus completion in 6 months, after that, there'll be 2 months for the revision. On every Sunday, we'll make you write the chapter-wise mock tests. Whatever chapters we complete in a particular week, all those chapters, right? Whatever portion we complete in a week, you'll be writing the test on the Sunday of that particular week, right? You will have one-on-one mentorship sessions with all of us, one by one, so that we keep on telling you how to improvise your scores, etc., etc. And my dear students, at the end, just follow us blindly in this batch. We are taking the responsibility of taking you guys to your dream college through the NEET 2025 examination. But just do whatever we tell you to do. Nothing apart from that. Nothing apart from that. Yeah? Okay? So with this, I'm taking a leave. Link is there in the description box. Click on the link and get enrolled into the Phoenix 2.0 NEET English batch right now after this. And do let me know, all the students who watched this particular session, do let me know in the comment section of this particular video, did you actually enjoy the session? Did you actually learn the things, right? What was the feeling of the first session, right? And you can take the screenshot of this. Perfect. You can post it on your Telegrams, on your Instagrams, tag us personally. We'll repost the stories and let everyone know that Unacademy NEET English team is the best. Take care. God bless you all and love you all. Bye-bye.